Hello students, today we will learn about the composition of petroleum hydrocarbons. Petroleum is primarily composed of various hydrocarbons. It is still impossible to state exactly how many types of hydrocarbons are in petroleum. But it has been confirmed that the hydrocarbons in petroleum mainly consist of three types: alkanes, naphthenes, and aromatic hydrocarbons. Generally, natural petroleum does not contain unsaturated hydrocarbons like alkenes or alkanes. Only in secondary processing products of petroleum and in shale oil produced from oil shale can varying amounts of alkenes be found. From the chart showing the distribution of hydrocarbon groups in petroleum, we can see the distribution of each group. Each group discuss what is the distribution pattern of each hydrocarbon group in petroleum. Let's look specifically at the distribution characteristics of each hydrocarbon type. First, let's summarize the alkanes in petroleum. Alkanes are saturated hydrocarbons in petroleum with branched or straight chains and no ring structures known as alkanes or chain hydrocarbons. They are chemically inactive. C1 to C4 are gaseous at room temperature and pressure. C5 to C15 are liquid, and alkanes above C16 are solid. Depending on the type of petroleum, the alkane content can be as high as 50 to 70% or as low as 10 to 15%. In petroleum, alkanes generally have higher content than isoalkanes. As the boiling point increases, the content of both alkanes and isoalkanes in petroleum gradually decreases. Now, naphthenes in petroleum. Naphthenes are cyclic saturated hydrocarbons for six-membered rings. Their properties are relatively stable. The naphthenes abundantly present in petroleum are only the cyclo 5-carbon rings and the cyclohexane series, containing 6 carbon rings. In several major Chinese crude oils, the cyclohexane series is generally more abundant than the cyclopentane series. Besides monocyclic naphthenes, there are also bicyclic polycyclic naphthenes in petroleum. The connection mode of naphthene rings is mainly parallel linkage. Let's look at the aromatic hydrocarbons in petroleum. Aromatic hydrocarbons refer to molecules containing aromatic rings and possibly side chain groups. Both monocyclic and polycyclic aromatic hydrocarbons have been found in petroleum, among which the benzene, toluene, and naphthalene series with C1-C3 side chains have the highest content compared to alkanes and naphthenes. The aromatic content is relatively low, varying approximately between 10% and 20%. As the boiling point of the fraction increases, the aromatic hydrocarbon content, number of aromatic rings, number of side chains, and side chain length all increase. Students, think about it. The structure of petroleum hydrocarbons is very complex, but we see that each hydrocarbon type can be considered to be composed of basic structural units. So, what should we use to represent these basic structural units? We generally use the alkyl group, naphthenic ring and aromatic ring as the basic structural units. Then we can use the percentage of carbon atoms on these three structural units to describe the molecular composition. Here we stipulate the percentage of carbon atoms on aromatic rings relative to the total carbon atoms in the molecule is denoted as %Ca. As we can see, A is the abbreviation for aromatic ring. The percentage of carbon atoms on naphthenic rings relative to the total carbon atoms in the molecule is denoted as %Cn. The percentage of carbon atoms on alkyl side chains relative to the total carbon atoms in the molecule is denoted as %Cp. The total number of rings in the molecule is denoted as Rt. The number of aromatic rings is denoted as Ra. The number of naphthenic rings is denoted as Rn. Based on the representation of structural composition we just learned, can students calculate the structural composition of the following molecular formula? Looking at this molecular formula, let's calculate %Ca, %Cn, %Cp. Total ring number Rt, aromatic ring number Ra, and naphthenic ring number Rn. Students, check if you calculated correctly. Next, we will learn about the hydrocarbon composition of petroleum fractions. First, let's look at the hydrocarbon composition of petroleum gases. Petroleum gases can be divided into two categories based on their source: natural gas and refinery gas. First, let's look at the composition of natural gas. Natural gas is divided into associated gas and non-associated gas. Associated gas is further divided into pure gas field, natural gas, and condensate gas field. Natural gas. Condensate gas fields have both gas and liquid phases. Gas hydrate flammable ice is an ice-like crystalline substance formed by natural gas and water under high pressure and low temperature. It looks like ice and can burn when exposed to fire, hence named flammable ice, solid gas, or gas ice. Natural gas hydrate is distributed in deep sea or terrestrial permafrost. After combustion, it only produces a small amount of carbon dioxide and water with pollution, far less than coal and petroleum. Moreover, its reserves are huge, so it is internationally recognized as a substitute energy source for petroleum. Next, let's look at refinery gas. Refinery gas is the gaseous hydrocarbon byproduct from petroleum refineries. It mainly comes from processes like crude oil distillation, catalytic cracking, thermal cracking, petroleum coking, hydrocracking, catalytic reforming, hydrotreating, etc. Refinery gases from different sources have different compositions. The main components are alkenes and alkanes below C4 hydrogen, and small amounts of gases like nitrogen and carbon dioxide. Let's look at this table showing refinery gases obtained from different processing methods. Students, what conclusion can you draw? We can see that the component proportions of refinery gas obtained from each process are different. And we also find that alkenes are commonly present in refinery gas. Regarding the hydrocarbon composition of gasoline fractions, based on gas chromatography analysis of domestic gasoline fractions, it is found that in straight-run gasoline fractions among alkanes, naphthalene and aromatics, alkenes and naphthalenes constitute the majority of the straight-run gasoline fraction. Moreover, the content of N-alkenes is relatively high among isoalkenes. The content of isoalkanes with one methyl branch is relatively high. Naphthenes generally only include the cyclopentane and cyclohexane series. In the cyclohexane series, methyl cyclohexane has the highest content. The total aromatic content is relatively low, generally not exceeding 20% by mass. Especially the benzene content is relatively low. While toluene and xylene have relatively higher contents among the three xylene isomers, M-xylene has the highest content. Additionally, as the boiling point increases, the aromatic content gradually increases. For the hydrocarbon composition of middle and high boiling point petroleum fractions, middle distillates generally refer to the composition in the 200 to 350 degrees Celsius range. Their characteristics are for alkanes. The distribution mainly includes N and isoalkanes around C11, C20, increasing with the fraction's boiling point. For naphthenic aromatics, they are mainly mono and bicyclic. The content of tricyclic and above is relatively small. High boiling point fractions generally refer to the composition. In the 350 to 500 degrees Celsius range, they mainly include N and isoalkanes from about C20 to C36 within the fraction range. Their content decreases as the fraction boiling point rises. The number of rings in naphthenes is generally 1 to 6. The ring types are mainly cyclopentane or cyclohexane series. The structures are mainly fused type. Aromatics are mainly mono, bi, and tricyclic, while also containing a certain amount of tetracyclic and a small amount of aromatics with more than 4 rings. Most polycyclic aromatic hydrocarbons are also fused outside the aromatic rings. They're often naphthenic rings with varying numbers of rings. In this section, we mainly explained 1. The hydrocarbon composition of crude oil. 2. The structural composition of crude oil. 3. The hydrocarbon composition of petroleum fractions. These 3 parts, students. That is all for this lesson. Goodbye, students.